Hello everyone, welcome back to the Atharva Academy. Myself Chinmay Dhaduk. In this video, we are going to start solving GATE questions of Chapter 4, Shear Force and Bending Moment Diagram. Now this is the first question from year 2001. The shape of the bending moment diagram for a uniform cantilever beam carrying a uniform distributed load over its length is dash. So we have one cantilever beam like this and we apply uniform distributed load over this beam. Here we have to find the shape of bending moment diagram, and these four options are given: a straight line, an ellipse, hyperbola or parabola. Now we know that how to find bending moment diagram for this type of beam. Here to find bending moment diagram, first of all we take one section at distance x from this end. And here we take this point as origin and this direction as x direction. So at this point x is equal to 0 and at this point x is equal to L, right? Now first of all we have to find out shear force at this section. And we know that shear force is the integration of uniform distributed load with respect to x. Here this uniform distributed load is constant and it is in the downward direction. So here we will take integration of minus w with respect to x. So it is actually minus wx. Now if we want to find out bending moment diagram in this beam, then we have to take integration of shear force with respect to x, right? So it is integration of minus wx with respect to x. So it is equal to wx square by 2 plus constant of integration c, right? Now we know that at the free end, if there is no any bending moment applied like this, then value of bending moment at the end is 0. So here we can say that at x is equal to 0, bending moment is 0. And if we will put this boundary condition here, then value of c will be 0. So actually bending moment is minus wx square by 2. Fine. Now from this expression we can find out the shape of the bending moment diagram for this type of cantilever beam under uniform distributed load. We know that if in the equation of bending moment diagram power of x is 1, then shape of bending moment diagram is straight line, right? Here power of x is 2. So we can say that shape of the bending moment diagram will be parabola. And if here the power of x is 3, then shape of this bending moment diagram will be cubic curve. So here power is 2, so shape of bending moment diagram is parabola. Fine. Now if instead bending moment diagram, if we want to find out shape of shear force diagram, then what will be the answer? Here in the equation of shear force we can see that power of x is 1, right? So here this is the equation of straight line. So the shape of shear force diagram is straight line and shape of bending moment diagram is parabola. So here our answer is option D, and this question is for 1 mark. Now the next question is from year 2003. A concentrated load P acts on a simply supported beam of span L at a distance L by 3 from left support. So here it is simply supported beam and length of this beam is L. Here we apply this concentrated load P at a distance of L by 3 from left support. So this distance is L by 3 and this distance will be 2L by 3. Here we have to find out bending moment at the point of application of the load. Means at this point we have to find out bending moment. Here this load is having value P, right? Due to this load there will be two reactions at these ends. Here this load is applied in downward direction, so this reaction will be in upward direction. Let's say this reaction is R1 and this reaction is R2. Now first of all we have to find out reaction 1 and reaction 2. To find out these reactions, we will use equilibrium condition. we know that this beam is in equilibrium, and for the equilibrium, summation of forces is equal to 0 and summation of bending moment is 0. Now here, if we take summation of forces in vertical direction, then we can say that R1 plus R2 is equal to P. Now if we take summation of moment about any point of this beam, then it will be 0, right? So let's say here we take moment about this point, and here we will take clockwise moment as positive and anti-clockwise moment as negative. Now at this point there will be two moments by these two forces. Moment by this P load will be P into perpendicular distance L by 3. So it is P into L by 3. And here moment by this P load will try to rotate this beam clockwise direction with respect to this point, right? So it is positive. Now we will take moment by this reaction R2. That will be R2 into perpendicular distance L. So it is R2 into L. And here moment by this reaction will try to rotate this beam in anti-clockwise direction with respect to this point. So it will be negative. And moment by this reaction R1 will be 0, because there is 0 distance between this load and this point, right? So summation of this moment is 0. From here we can find out R2, that is P by 3, right? And if we put R2 is equal to P by 3 here, then we can find out R1, and R1 is 2P by 3. Fine. So now we have value of reactions at these both ends. Now we know that if we want to find out bending moment at any section, then first of all we take section at that point, and we take summation of all the moments acting on this beam either side of this section. Now let's say here we take summation of all the moments acting on the left side of this section. So on the left side there is only one reaction, R1. So moment at this point will be R1 into this perpendicular distance, that is L by 3. Now R1 is 2P by 3. So it is 2P by 3 into L by 3. So it is 2PL by 9. Fine. And here if we take summation of moments right side of this section, then it will be R2, that is this reaction, into this perpendicular distance 2L by 3. And R2 is P by 3 into 2L by 3. So here our answer is 2PL by 9, right? So in both the cases we are getting same value. So here our answer will be option D, 2PL by 9. And this question is for 1 mark. Now the next question is from year 2005. A cantilever beam carries the anti-symmetric load shown here, where W0 is peak intensity of the distributed load. Here at this point it is W0, and at this point it is W0. Qualitatively, the correct bending moment diagram for this beam is dash. Here we have to find out bending moment diagram for this cantilever beam under this type of distributed load. To find the bending moment diagram in this beam, first of all we will take this B point as origin, and here we will take this direction as x direction. So at this point x is equal to 0, at this point x is equal to L, and at this point x is equal to 2L, right? Because here distance is L and L. Now we can solve this problem by two methods. First of all we can take two intervals. One is 0 less than or equal to x less than or equal to L, and second interval is L less than or equal to x less than or equal to 2L. First of all, in both the interval we have to find out Wx, that is the value of uniform distributed load at x section from this point. And then we have to find out shear force, that is the integration of Wx with respect to dx, and then we have to find out bending moment, that is the integration of shear force. Now in the interval of 0 to L, what is the value of Wx? Here at the x is equal to 0, at x is equal to 0, value of wx is maximum, that is w0, right? And at x is equal to L, value of wx is 0, right? Now here we have to find out wx, means here we have to find out equation of this line in terms of x. By using these 2 points, we can find out equation of this line. And if you will find this equation, then it will be 1 minus x by L into w0. Here if you put x is equal to 0, then wx is w0, and here if you will put x is equal to L, then it is 0. Fine. Now to find shear force, we have to integrate wx with respect to x. So if you will integrate this, then it is w0x minus x square by 2L into w0 plus constant C1. Now we know that at x is equal to 0, value of shear force is 0. So here value of C1 is 0. So we have equation of shear force in this beam in interval 0 to L. Now if we want to find out bending moment, then it is the integration of shear force with respect to x. To find out bending moment, we have to integrate this expression. So if you will integrate this, then it is w0 x square by 2 minus x cube by 6L into w0 plus C2, that is constant for this integration. Now we know that at this free end there is no any moment applied like this. So value of bending moment at x is equal to 0 is 0. So if you will put this boundary condition here, that at x is equal to 0, m is equal to 0, then here value of C2 is 0. So finally we have equation of bending moment in this beam in the interval of 0 to L. Now from this expression we have to decide that curvature of this bending moment diagram in this interval will be in upward direction or it will be in the downward direction. For that we have to take double differentiation of this bending moment equation. Now here if you will take double differentiation of m with respect to x, then it will be this expression. Why? Because integration of this term is shear force and integration of this shear force is bending moment. So first differentiation with respect to x of this bending moment will be this expression, right? And second differentiation with respect to x of this shear force will be this expression. So finally double differentiation of this bending moment is this term. And here if you will put any value of x between this interval, then this value will be positive, right? So we can say that curvature of this bending moment diagram in this interval will be upward. So it will be something like this. So here this curvature is not correct and this curvature is not correct. Here in option B and C, in this interval we have this curvature in upward direction, right? So our answer will be from this option B or C. Now we have to use this same method in interval L to 2L. First of all we have to find out Wx, then we have to find out shear force and bending moment. Now in the interval of L to 2L we want to find out bending moment diagram. For that we will take one section at a distance of x from this point B. In this interval first of all we have to find out Wx. Here we know that at this point where x is equal to L, Wx is 0. And at x is equal to 2L, value of this Wx is minus W0. Now here we have these 2 points, and by using these 2 points we want to find out equation of this line. So by using these 2 points, if you will find the equation of this line, then it will be similar as discussed in this interval. It will be 1 minus x divided by L into W0. Here if you will put x is equal to L, then you will get 0, and if you will put x is equal to 2L, then you will get minus W0. Fine. Now we have to find out shear force, that is integration of Wx with respect to x, and if you will find this F, then it will be W0x minus x square by 2L plus C1. Now what will be the value of bending moment? It is integration of shear force with respect to x. So it is integration of this expression. So it is W0 x square by 2 minus x cube by 6L plus C1x plus C2. Here we don't have to find out C1 and C2, because here we will directly find d square m by dx square. And from here we will find curvature of this bending moment diagram in the interval of L to 2L. Now what will be the double differentiation of bending moment equation with respect to x? If you will take first differentiation of this bending moment equation, then it will be this equation, right? And if you will differentiate this shear force with respect to x, then you will get this term. So here d square m by dx square is 1 minus x by L into W0. Now we have to put value of x anything between L and 2L. And if you will put any value between L and 2L in this expression, then you will get this value negative, right? Here we are getting d square m by dx square negative in this second interval, means curvature of this bending moment diagram will be in downward direction. So it will be something like this. And here we have these two options, B and C, right? And in this C option, you can see that in this interval, this curvature is in the downward direction. So here our answer will be option C, and bending moment diagram will be something like this. From here to here, it is having curvature in the downward direction, and from here to here, it is having curvature in upward direction. So I hope that you understand this question. Here this method is one method to find out this bending moment diagram. Now I will just tell you other method to find out this bending moment diagram in this beam. In the second method, we will add one uniform distributed load in downward direction like this, and we will add one another uniform distributed load over this beam, and that will be in upward direction like this. And here value of this both the uniform distributed load is W0, and here also it is W0. Now let us draw equivalent cantilever beam here. Now first of all, let us draw this uniform distributed load over this beam. So it will be like this, and it is in the upward direction. Now we have to take summation of this uniform distributed load and these two distributed load, right? Now understand carefully that at this point, at point B, this uniform distributed load is in the downward direction having value W0, and this distributed load is in the upward direction having value W0, right? So summation of both this load will be 0 at this point. Now at this point there is no any distributed load here, but there is only one distributed load, that is uniform distributed load having value W0 at this point, and it is in the downward direction. So at this midpoint, value of uniform distributed load is W0, right? And now at point A, you can see that this uniform distributed load is in the downward direction having value W0, and this distributed load is also in the downward direction having value W0. So actually at this point, this total distributed load will be 2W0, right? So if we take summation of this uniform distributed load and this load acting over this beam, then it will be triangular load like this. It is in downward direction like this. Here this value is W0 and here maximum value of this uniform varying load is 2W0. So actually we have converted this type of loading in this type of 2 loading. It has two type of distributed loading. One is uniform distributed load acting in the upward direction and second is uniform varying load acting in downward direction. Now by converting this type of loading in this type of loading condition, we can find the value of bending moment by using only one interval. Here we have to take only one interval 0 to L, 0 to 2L. Here at this point x is equal to 0 and at this point x is equal to 2L, right? And here what will be the value of Wx? Now we can take summation of these both the distributed load. So Wx at any section at distance of x from this point will be W0, that is value of this uniform distributed load, and it is in the upward direction on the right side, so it is positive minus x by L into W0. This term is value of Wx for this uniform varying load and it is in the downward direction, so here we have taken this negative sign. Here you can see that if you put x is equal to 0, then value of this uniform varying load is 0 at this point, and if you put x is equal to 2L, then you will get uniform distributed load at this point, that is 2W0. Fine. Now we have to follow same method. We have to find out shear force, that is integration of Wx, and then we have to take integration of shear force to find out bending moment. After finding the value of bending moment or after finding the equation of bending moment, we have to take d square m by dx square. And after getting expression of d square m by dx square, we have to check value of d square m by dx square in two intervals, in interval 0 to L and in interval L to 2L. Here if you will put any value between 0 to L, then you will get this value as positive, and if you will put any value of x between L to 2L, then you will get this d square m by dx square negative. Means in the interval of 0 to L, curvature will be in the upward direction, and in the interval of L to 2L, curvature will be in the downward direction. Here double differentiation of this bending moment equation will be this term, and you can put this value in this expression. Here if you will put value of x between 0 to L, then you will get positive value, right? So in this interval curvature is in the upward direction, and here if you will put any value between L to 2L instead of this x, then you will get negative value, right? So curvature of this bending moment diagram will be in the downward direction in this interval. So from here we can also find this bending moment diagram, and here our answer is option C. So I hope that you understand how to find bending moment diagram and how to decide what is the curvature of this bending moment diagram. Now this next example is from year 2005. A beam is made up of two identical bars AB and BC by hinging them together at B. Here in the figure you can see that these two beams AB and BC have same length and same cross section area, and both the beams are hinged at this point B. What is the meaning of this hinged? Means if let's say this support is not there, then this BC beam can rotate with respect to this AB beam about this point. Means this BC beam can rotate like this with respect to this hinge. But here there is one support, so actually this beam cannot rotate with respect to this hinge. The end A is built-in cantilevered, that is shown here, and the end C is simply supported, that is shown here. With the load P acting as shown, the bending moment at A is dash. Here this P load is applied at a distance of L by 2 from this point B, means it is applied at the midpoint of this BC beam, and we have to find out bending moment at point A. Now see, here we cannot take section at point A directly, and we cannot take summation of all the moments acting on this beam right side of this section. First of all, we have to transfer this P load on this AB beam, because both the beams are not same. It is different beam that is hinged at this point. Fine. Here we can consider this example as two beams. One is cantilever beam AB and other beam is BC. That is, one is hinged at this point, point B, and at this point it is simply supported. Now we apply this point load P at midpoint of this BC beam, right? This distance is L by 2 and this distance is also L by 2. Now here this concentrated load P is acting at the midpoint, so reaction at point B and point C will be P by 2, right? And here we are getting reaction at point B having value P by 2. Means in this beam we will get one point load in this direction having value P by 2. Right? So by this load P, there will be P by 2 load on this AB beam at point B. I hope that you understand why this P by 2 load is acting on this AB beam in downward direction. Here this P by 2 load is the reaction on this beam BC. But this reaction will act on this AB beam and it will be act as a point load P by 2. And here this distance of beam AB is L. Now we can directly find the value of bending moment at point A. That will be this load P by 2 into this perpendicular distance L. So here our answer is PL by 2. That is the value of bending moment at this point. So I hope that you understand this question. This question is for 2 marks. And here you can get some variation in this example. Here this distance may be L by 3 from this end. If this distance is L by 3, then these reactions will be not P by 2, P by 2. It will be different, right? For that, we have to use two equations, sigma f is equal to 0 and sigma m is equal to 0. Or you can directly use one shortcut, that if this P by 2 load is acting at L by 3 distance from this end, then reaction at point C is equal to this P load into opposite distance, means distance between this load and opposite end, that is L by 3, divided by total distance between B and C, that is L. So it is P by 3. And if we want to find out reaction at point B, means if we want to find out RB, then it is this load P into opposite distance, means distance between this load and C, that is 2L by 3, divided by total distance between point B and C, that is L. So RB will be 2P by 3. And here RB is 2P by 3, means here this reaction will be 2P by 3 and here this load will be 2P by 3. And in that case, value of this bending moment will be 2P by 3 into L at this point A. So in that case, answer will be 2PL by 3. Fine. I hope that you understand this question from chapter 4. In next video, we will discuss further questions from this chapter. Now in this video, we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.